All right, now that we know all the basic operations with radicals and how to simplify them, we're going to talk about one of the main ways that you see radicals, and that is using this really cool thing called the Pythagorean Theorem. Now, you may have heard of this before, you may have maybe even got a brief little intro to it before, and we're going to get really deep into the Pythagorean Theorem now, and we're also going to hit it again next year when you get to geometry because it is just so important. This is one of those things that you will definitely use in your real life. All right, so here's a really cool Pythagorean Theorem video, and this is about how it shows up in NFL football. So for you football fans out there, it's a cool way of how math shows up in places you'd never expect it. But it's also, if you're not a football fan, it's a really cool way to think of math in a real world situation outside of just those word problems that we usually do. So take a couple minutes and watch that video. All right, I hope you really liked it. But now let's talk about the basics of the Pythagorean Theorem, which if you watched the video, you saw some of that already, right? So the Pythagorean Theorem only works in right triangles. So notice when we have this angle that's marked right here with our little box, right? That's how we mark a right angle in a picture in math. So here we always have right triangles. So only works for right triangles. You'll get into the really specific details of why that is when you get into geometry, but for right now, just know that this only works for a right triangle. Now, when we have a right triangle, we have some vocabulary that goes along with it. Hopefully, the first bit of vocabulary you already know, and that is what the side across from the right angle is called. The side across from the right angle is called the hypotenuse, right? That hypotenuse is always across from the right angle, but it's also always the longest side. All right, and again, you'll get into why that is when you get into geometry, but just so that you know, it's always true of every right triangle, the side across from the right angle is always the longest side, and that side we call the hypotenuse. Now, these other two sides that are not the hypotenuse, those are both called legs. And it doesn't matter, leg 1, leg 2, doesn't matter. They're just both legs. And the side across from the right angle is called the hypotenuse. All right. Now, the Pythagorean theorem actually says a squared plus b squared equals c squared. Well, what the heck does that mean, right? A squared plus b squared equals c squared. And what that is when we say that, we'll say the side across from the right angle, the hypotenuse, this is always side C, okay? So the hypotenuse is side C, and then each of the legs are side A and side B. So if you wrote this Pythagorean theorem out in words, it would be, if you have a right triangle, then the sum of the squares of the legs equals the square of the hypotenuse. Or leg squared plus leg squared equals hypotenuse squared. If you have a right triangle, leg squared plus leg squared equals hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. That's what the Pythagorean theorem is. Now, it seems kind of complicated, but once you see how we use it, it is so cool. But just remember, you have to have a right triangle because a right triangle is the only one with a hypotenuse. So you've got to know which side is the hypotenuse for this to work. All right, so let's see how this works in action. So here, notice I have my right triangle. I see my right angle right down here in the corner, okay? And I see that two sides I know the length of, 9 and 12. I don't know the length of the third side. And this is the perfect situation. This is exactly what we use the Pythagorean theorem for, okay? So remember, Pythagorean theorem says a squared plus b squared equals c squared, right? C is the hypotenuse. So the first thing that I always do is I see if I can find, here's my right angle, So then I figure out which side is the hypotenuse, right? So this right here, this is the hypotenuse. This is side C. So that means that 9 would be A, 12 would be B. It doesn't really matter the order on that because you're just going to add the two together, so you can change the order. Either one could be A and either one could be B. But you have to know which side is going to be C. So how this works is I would say 9 squared plus 12 squared equals C squared. And I'm going to use this idea to solve for C. Okay, so 9 squared is 81 plus 12 squared is 144, and that's going to equal C squared. Well, 81 plus 144, that would be 225 equals C squared. Now, I want to figure out C, not C squared. So if you remember, the opposite of squared is to square root. So I'm going to square root both sides. A squared and a square root cancel out, right? So C equals the square root of 225, which I know is a perfect square, and so that would give me 15. And that's how you use the Pythagorean theorem. Start out by figuring which side is C, set up your equation, a squared plus b squared equals c squared, and then solve. And remember that to clear a squared, the opposite of squared is square root. So you're going to square root both sides. And this is why it's in this radical unit, because at the end, in order to solve this problem, I'm going to have to take a square root. And you need to know how to find the square root of a perfect square, but a lot of times you're not going to have a perfect square, and so you'll also have to simplify those answers unless they tell you to round, which they most likely won't. All right, let's try it out this time. So here again, I have the length of two sides of a 10 and a 14, and I'm missing one of the sides. So again, here, first step, decide which side is C. Side across from the right angle is C. So 14 is going to be C. Now I notice that one of these sides is already labeled with a B, so that means the 10 must be A, right? So A squared plus B squared equals C squared is what I'm going after. You don't have to write that part down, but just so that you know why I'm putting the numbers where they go. So that would be 10 squared plus B squared equals 14 squared. Now this is a little bit different, right? A little bit different order, but that's okay. Let's still do our perfect squares here. So 10 squared is 100 plus B squared equals 14 squared is 196. Now be careful. Think about where your B squared is here, right? I'm trying to get that B by itself. So instead of combining 100, I have to move the 100 to the other side to get this B squared by itself. So I'll have B squared equals 96. And now to clear the squared, my last step here, square root both sides. Squared and square root cancel out, so I'll get just plain old B. But now I have the square root of 96. Now that's not a perfect square, right? So I have to see if I can simplify the square root of 96. That would be 3 times 32. Oh, maybe I would have a 16. How about 4? 4 times... Well, I know a 4 will go into it. 24. Think I could go bigger. Okay. How about 16 times... Let's see, would that be 16 times 6? Ah, yeah, there we go. Okay. So remember how to reduce those radicals from back at the beginning of this unit. This is why we do it. So our perfect squares here, as perfect square is 16, so I have 4 radical 6. So B equals 4 radical 6 is my final answer here on this one. So notice in the last one, we were trying to find C, which is why we could just combine everything on the same side, take the square root, happened to be a perfect square on that one, so it worked out great. On this one, I was finding one of the other sides. I knew what C was, and I was finding one of the other ones. So you had to rearrange your equation a little bit after you get things plugged in. And then this one was not a perfect square, so I had to use my simplifying radicals idea that we learned at the beginning of this unit. So that's kind of putting things together. All right, so let's see about this one now. So again, given two side lengths, it's a right triangle, finding the third. So the first step is to figure out which side is the hypotenuse. So C is going to be 10 radical 2. Now these other two, I can call either one A and B. That doesn't really matter, right? So I will have 10 squared plus n squared equals, now be careful here, I need all of 10 radical 2 to be squared. I need to square the whole thing, right? So that means, let's see, 10 squared is 100 plus n squared equals, now if I need to square this whole thing, that means I need to square the 10 and I need to square the square root of 2. Now you can think of this is okay to do because remember I'm multiplying, that's like our power of a product, right? It just happens that one of the things I'm multiplying in there is a radical, but that's okay. So 10 squared, that would be 100 times radical 2 squared would be 2. So I have 100 plus n squared equals 200. 100 times 2, right? This is what I just did. Now I'm trying to figure out what n is, so I'm going to subtract 100 from both sides. So I get n squared equals 100. Oh, that's going to work out nicely. I'm going to square root both sides to get rid of the squared. Squared and square root cancel, so I get n equals the square root of 100, which is 10. So if one of your sides has a radical in it already, remember you're going to distribute that exponent and square both parts there. All right, so hopefully you're getting the hang of that. Hopefully you got a pretty good feeling on how to use that Pythagorean theorem to find missing side lengths, right? That's what these last three problems have been, pretty much however you can see them. Now, this next couple of questions says, tell whether each triangle with the given side lengths is a right triangle. So what they're saying is, in number 4, if a triangle had sides of 9, 40, and 41, would that triangle be a right triangle? Yeah, we could draw it out, right? But our measurements might not be perfect. And even if they were, would we be able to tell if we had a right angle in there? I'm not sure. How could we use the Pythagorean theorem to figure this out? Well, the Pythagorean theorem was a squared plus b squared equals c squared, right? But we said this is only for right triangles. So that means if a squared plus b squared equals c squared, then it has to be a right triangle. And if it doesn't equal, then it can't be a right triangle because this always works for right triangles, but it doesn't work for any other kind. So we're going to set this up, test it out, and if it equals, then it is a right triangle. And if it doesn't equal, then it's not a right triangle. The trick is to know which side is c. How do I know which one of these numbers to put by itself on the other side? Well, remember that c is the hypotenuse in a right triangle, and we said that the hypotenuse is always the longest side. So if you look at your list of numbers here, the longest one would have to be c, and the other two would be a and b. So here I would have 9 squared plus 40 squared equals 41 squared. All right, so 9 squared is 81. 40 squared is 1600. 41 squared, probably have to get your calculator out for that one. Let's see, I'm pulling mine up over here on the side, and I'm going to type in 41 squared, which gives me, there it is, 1681. Ah, okay, this is looking good. Now remember, you're not done until you prove it. 81 plus 1600 gives me 1681, and 1681 equals 1681. So yes, this one is a right triangle. So you plug it in and you make sure that it actually equals. Now be careful that you need to include this step right here That's a very important step. Don't leave it to other people to make sure that see if they can do their arithmetic, okay? Prove it by going all the way to that last step. Show me one number on each side. Do they equal yes or no, okay? So let's see about number 5. See if you can do this one. 20, 25, and 7. All right, so again, you're looking for which side is the longest one. So the 25 would have to be C. So if I'm setting up my equation here, it would be 7 squared plus 20 squared equals 25 squared. Now, it's okay if you wrote 20 squared plus 7 squared. Same thing, right? You can change the order when you're adding. 7 squared is 49. 20 squared is 400. 25 squared is 625. So this gives me 449 equals 625. Oh, yikes, that's not true, right? That does not equal. So this is not a right triangle. So there you can see that you have to go all the way down to that last step where you have two numbers, one on the left, one on the right. And if they equal, it's a right triangle. If they don't equal, it's not a right triangle. So this is what we call the converse of the Pythagorean theorem. Converse just means kind of like the opposite. So the Pythagorean theorem, says that if you have a right triangle, then a squared plus b squared equals c squared. The opposite would say if a squared plus b squared equals c squared, then you have a right triangle. So that's how we can use the Pythagorean theorem in a different way. So just to wrap it up, big deal here. Pythagorean theorem, a squared plus b squared equals c squared. C is the hypotenuse, or the longest side, or the side across from the right angle, and it only works for right triangles. So if you have a right triangle, you can always use this to find a missing side. If you have all three sides and you don't know if it's a right triangle, see if it works. If it works, then it's got to be a right triangle.